Welcome to Thinking Mathematically. We're going to start on Chapter 10, Geometry. Now, since we skipped Chapter 9, you may want to go back and review some of the units of measure because you will need to have a good understanding of those for this chapter. This is Section 10.1, Points, Lines, Planes, and Angles. The objectives: understand points, lines, and planes as the basis of geometry, solve problems involving angle measures, and solve problems involving angles formed by parallel lines and transversals. We're going to define points, lines, and planes. A point is represented by a small dot, and it has no length, width, or thickness. It's usually designated by a capital letter. A line connects two points along the shortest path, but it has no thickness and it continues in both directions. A plane is a flat surface. It has no thickness and no boundaries. A line may be named using any two of its points. A half line is formed when a point divides a line. A ray is a half line with its endpoint included, and a line segment is a portion of a line joining two points. And this is demonstrated on the next slide. A closed circle indicates that the point is included. An open circle indicates that the point is not included. So for a line AB, the points A and B are included, but the line goes in opposite directions. And we designate this by AB with a double arrow over the AB or with BA with a double arrow. It can go either way. A half line means that A is not included, so it's an open circle, but it does extend through point B and then continues. A ray starts at point A and goes through point B and continues. And then a line segment, AB, is just that. It goes from point A to point B, and you can see the designator, which is an AB or BA, and it's got just a line over it. Angles are formed by the union of two rays. One ray is called the initial side, the other ray is called the terminal side, and the common point is called the vertex. So we can name the angle formed in this diagram as angle 1. We can name it angle B, which is the vertex, or we can name it as angle ABC or CBA. If you use all three letters, the vertex must be indicated in the center. Angles are measured by the amount of rotation from the initial or starting side to the terminal or ending side. They're measured in degrees, and there are 360 degrees in a full rotation or a circle. So 1 degree would be 1/360th of a complete rotation. Example 1, using degree measure. The hour hand of a clock moves from 12 to 2 o'clock. Through how many degrees does it move? If we look at the diagram, we see that going from 12 to 2 is 2/12 of a complete revolution. This reduces to 1/6. So we are going to take 1/6 of the complete revolution, 360, which gives us 60 degrees. We can classify angles by their degree measurement. An acute angle is less than 90. A right angle is exactly 90 degrees. An obtuse angle is greater than 90 degrees but less than 180 degrees. And a straight angle is exactly 180 degrees. Protractors are used for finding the degree measure of an angle. You measure the angle by placing the center point of the protractor on the vertex of the angle and the straight line of the protractor along one side of the angle. You read the degree by reading where the other side of the angle intercepts the edge of the protractor, and you would choose a number based on whether the angle is obtuse or acute. This is an acute angle is less than 90 degrees, so we're going to use the inside measurement for this protractor, which says it's 50 degrees. Complementary angles are two angles whose sum is 90 degrees. To find the complement of an angle, subtract it from 90. So the complement of 70 degrees is 20 degrees. Supplementary angles are two angles whose sum is 180. The supplement of 110 would be 180 minus 110, which is 70. Example 2, angle measures and complements. We want to find the measure of angle DBC. We're given the measure of angle ABD is equal to 62 degrees. We also know that angle ABC is a right angle by the little box at the vertex B. So to find the measure of angle DBC, we're going to take 90 degrees, the right angle, minus the 62 degrees, which gives us 28 degrees. The next example involves supplements. The measure of angle ABD is 66 degrees greater than the measure of angle DBC, and they are supplementary angles. That means that their sum is basically a straight line. We want to find the measure of each angle. So we know that the sum of the measures of the two angles is 180 degrees. If we let x represent the measure of DBC, then x plus 66 would be the measure of angle ABD because it's 66 degrees greater. Solving the equation, we have 2x plus 66 degrees is equal to 180. Subtract 66 from both sides. That gives us 2x is equal to 114. And divide by 2, we get x is equal to 57. But the problem asks us to find the measure of each angle. So we know that angle ABD is 66 degrees greater than angle DBC, which makes it 123 degrees. You can add the two together and find that their sum is 180, which would be correct. Next, vertical angles. When two lines intersect, the opposite angles formed are called vertical angles. So angle 2 and 3 are equal because vertical angles are equal, and angle 1 is equal to the one across from it, which is 68 degrees. We want to find the measure of the other angles. As we said, angle 1 is equal to 68 degrees. We know that angle 1 plus angle 2 is 180 because those are supplementary angles. They form a straight line. So solving for angle 2, we're going to get 112 degrees. Angle 2 and 3 are equal, so angle 3 is also equal to 112 degrees. Lines that lie in the same plane and have no points in common are called parallel lines. Two lines that are not parallel and have a single point in common are called intersecting lines. A transversal is a line that intersects two parallel lines. You can see from the diagram at the right that the transversal intersecting the two parallel lines creates 8 angles, and we're numbering them 1, 2, 3, 4, 5, 6, 7, 8. You can also see that by looking at each part, we have vertical angles which are equal. In other words, angle 1 is equal to angle 4, angle 2 is equal to angle 3, and so on. But there's some other relationships too. And you might need to look in your book at table 10.1 for these because they're a little bit small. But we have alternate interior angles. They don't have a common vertex. And they're on opposite sides of the transversal. So in the diagram, 3 and 6, 4, and I'm having trouble reading that, 5 are alternate interior angles. Alternate exterior angles do not have a common vertex and they're on alternate sides of the transversal. So we have 1 and 8, and 2 and 7. Corresponding angles, one interior angle and one exterior angle on the same side of the transversal. And you can see that these are angles 1 and 5, 2 and 6, 3 and 7, 4 and 8. They had the same measure. So we're going to utilize these properties as to which angles are equal to solve problems. If parallel lines are intersected by transversal, alternate interior angles have the same measure, alternate exterior angles have the same measure, and corresponding angles have the same measure. Conversely, if two lines are intersected by a third line and a pair of alternate interior angles or a pair of alternate exterior angles or a pair of corresponding angles have the same measure, then we can say the two lines are parallel. So we're going to pull all of this together with example 5. Finding angle measure when parallel lines are intersected by a transversal. So we're given two parallel lines that are intersected by a transversal. The different angles are numbered. And so we can use our relationships that we just looked at in table 10.1 to find all of these other angles. All you need is the measure of one angle. We're given that the measure of angle 8 is 35 degrees. Well, immediately we know the angle 1, which is a vertical angle, to angle 8 is also 35 degrees. Angle 1 plus angle 6 are equal to 180 degrees. They're supplementary. So angle 6 is 180 minus 35 degrees, or 145. Well, now we know the measure of angle 6. Angle 7 is a vertical angle to angle 6, so its measure is also 145. Okay, now we're going to deal with alternate interior angles and alternate exterior angles. The measure of angle 8 is 35 degrees, which means that the measure of angle 2 is also 35 degrees because it's an alternate interior angle. Because angles 2 and 3 are supplementary, subtracting 180 minus 35, we find that the measure of angle 3 is 145 degrees. We can do the same thing to find the measurement of angle 5, either subtracting from 180, or we see that angles 2 and 5 are vertical angles. That's probably the easiest way to go. So 2 and 5 are both 35 degrees. That gives us the measure of angle 4, which would be equal to angle 3 because they're vertical, or you can use the supplementary angles, would be equal to 145. So knowing the one angle, the measure of angle 8, we have found the measure of all of the other angles, all other 7 angles. And that concludes this section.